Okay, hi everyone, welcome back to this video series, Data Centers. WAN, a wide area network. There are legions of people who, if asked to define a wide area network, WAN couldn't do it, yet most of them use the big dog of all WANs, the internet, every day. With that in mind, you can imagine that WAN networks are what we use to span large geographic areas and truly go the distance like the internet. WANs usually employ both routers and public links, so that's generally criteria used to define them. Here's a list of some of the most important ways WANs are different from LANs. They usually need a router, port or ports. They span large geographic areas and or can link disparate locations. They're usually slower. We can choose when and how long we connect to a WAN. A LAN is all or nothing. Our workstation is either connected permanently to it or not at all, although most of us have a dedicated WAN links now. WANs can utilize either private or public data transport media like phone lines. We get the word internet from the term internetwork. An internetwork is a type of WAN that connects a bunch of networks or intranets. If an internetwork host still use hardware addresses to communicate with other hosts on the LAN. However, in an internetwork, hosts use logical addresses, IP addresses, to communicate with hosts on a different LAN, other side of the router, and routers are devices that make this possible. Each connection into a router is a different logical network. Figure 1.5 demonstrates how routers are employed to create internetworks and enable our LANs to access WAN resources. So you can see here's the WAN, the internet here, and 3 different routers. The internet is a prime example of what's known as a distributed WAN, an internetwork that's made up of a lot of interconnected computers located in a lot of different places. There's another kind of WAN referred to as a centralized, that's composed of a main centrally located computer or location that connects computers and devices that connect to it. A good example is remote office that connect to the main office as shown in figure 1.5. So here we can see here 1.5, the branch offices. Okay, network architecture, peer-to-peer or client and server. So we've developed networking as a way to share resources and information, and how that's achieved directly maps to the particular architecture of the network operating system. There are 2 main types you need to know about: peer-to-peer and client-server. And by the way, it's really tough to tell the difference just by looking at a diagram or even by checking out live video of a network coming along. The differences between peer-to-peer and client-server architectures are major. They're not just physical, there are logical differences. Peer-to-peer computers connected in peer-to-peer networks do not have any center or special authority. They're all peers, meaning that when it comes to authority, they're all equals. This means it's up to the computer that has the resources being requested to perform a security check for access rights to its resources. Also means that the computers existing in a peer-to-peer network can be the client machines that access resources and server machines that provide them to other computers. This works really well if there's not a huge number of users on the network. Each user handles backing things up locally, and your network doesn't require a lot of security. If your network is running Windows, Mac or Unix in a local LAN workgroup, you have a peer-to-peer network. Figure 1.6 gives a snapshot of a typical peer-to-peer network. Peer-to-peer networks present some challenges. For example, backing up company data becomes an iffy proposition. It should be clear by now that peer-to-peer networks are not all sunshine. Backing up all that super important data, it's only not vital, it's really challenging. What if you forget where you put a badly needed file? Haven't we all done that? And then there's that security issue to tangle with, because security is not centrally governed. Each and every user has to remember to maintain a list of users and passwords on each and every machine. Worse, some of all these all important passwords for the same users change on different machines, even for accessing different resources. Client server networks. Client server networks are pretty much a polar opposite of peer-to-peer networks, because in them a single server is specified that uses a network operating system for managing the whole network. So instead of the request going directly to a machine with the desired resource, the client machine's request for a resource goes to the main server, which responds by handling security and directing the client to the resource it wants. So here you can see this is a peer-to-peer network. There's no central server. So you have the hub and 4 client machines. This arrangement definitely has its benefits. First, because the network is much better organized and doesn't depend on users remembering where needed resources are. It's a whole lot easier to find the files you need, because everything is stored in one spot on that special server. Your security gets a lot tighter because all usernames and passwords are on that server, which by the way isn't ever used on a workstation. You even gain scalability. Client server networks can have legions of workstations on them, and even with all those demands, their performance is actually optimized. Check out figure 1.7. Looking at it, you can see a client server network with a server that has a database of access rights, user accounts and passwords. So here's our client server network model. Here's our server and 4 client machines. Many of today's networks are healthy, we hope. A combination of peer-to-peer and client server architectures with carefully specialized servers that permit the simultaneous sharing of resources from devices running workstation operating systems. Even though the supporting machines can't handle as many inbound connections at a time, they still run the server service reasonably well. If this type of service of a mixed environment is designed well, most networks benefit greatly by having the capacity to take advantage of the positive aspects of both worlds. So I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.